lecture series being organized by INAE Bhubaneswar chapter, SOA University, IIT Bhubaneswar, IMMT Bhubaneswar, and NIJAR Bhubaneswar. Friends, today actually we have great pleasure in having with us Dr. Sudeshna Sarkar, Professor Sudeshna Sarkar, the only lady so far. And I will request actually our friends to find out a few more for this distinguished lecture series. I am also trying. We'll definitely be successful by having 10 more lectures in the next 3 months that we have at our disposal. Now, so far as Professor Sudeshna Sarkar is concerned, she is a professor in the Department of Computer Science and Engineering, IIT Kharagpur, and also she holds a Distinguished Chair Professor. She is a fellow of INAE and former head of Department of Computer Science and Engineering, and former founding head of Center of Excellence in Artificial Intelligence, IIT Kharagpur. She did her BTech and PhD in Computer Science and Engineering, both from IIT Kharagpur, and MS from University of California, Berkeley. Her research interests are in natural language processing and in application of artificial intelligence and machine learning. Today, our talk will be actually deals with automated news content analysis using natural language processing and techniques to extract events and arguments, and for examining biases and variations in the news coverage. She will focus on identifying selection, coverage, and statement biases through both machine learning and large language modeling, LLM, based approaches. Key tasks include event extraction, stakeholder analysis, sentiment prediction, and bias detection, with a particular emphasis on few short and zero shot settings to enhance model generalizability across various news domains. Notable contributions include joint event extraction model, a natural language interface method for news aspects identification, and stakeholders classification using V-turning. Additionally, she will be exploring methods to mitigate sentiment bias in news articles using sentence rewriting techniques. This research introduces innovative methodologies, advancing computational journalism, and providing valuable tools for analyzing modern media narratives. Very, very important aspect, because we know what type of havoc actually media is creating today. So possibly our techniques will help in getting the essential content of the news media that we get through both electronic as well as the print environment. With these few words, I will now request Professor Sudeshna Sarkar to please present your talk.
Thank you, Professor Acharya, for the kind introduction and for inviting me to deliver this lecture. So thanks to INAE Bhubaneswar chapter, SOA University, and other organizations who are jointly hosting this seminar. So today I will talk about an application of natural language processing in analyzing content and show an application to news content analysis, especially to identify events, arguments, identify the biases that take place. So because there's a mixed audience, so I will try to keep this talk at a little high level and also talk about some of the methodologies which are used here. I'll try to do it at a high level, but I'll be very happy if you interrupt me and if you have any questions so that we can discuss that. So can you see my slide?
Yes, yes. It is
So,
visible, no problem.
Yeah, the talk is mainly based on the research work by my student Alapon Kuila, who has recently submitted his PhD thesis on the following topic: decoding news narratives, a journey through NLP techniques in content analysis. So most of the work is done by him, and I will be presenting it. So first, we want to understand why are we interested in news content analysis. So we look at a few specific domains. For example, in today's talk, we will focus on the socio-political domain. So as you all know, and Professor Acharya has also hinted, that what is reported in the news, that has an influence on public opinion and societal discourse. So we will like to understand how information is presented, how it is framed and disseminated. And for this, we will try to identify that how the same story is presented by different media houses and what type of variability it has and what type of bias it implies. And this may be either intentional or even unconscious bias. So for this, we want to examine how the news is presented, what aspects are covered, what sentiment is expressed, and whose point of view are given. So there are other type of news analysis work. For example, we have earlier worked on disaster news, but probably today we will not talk about. So if we look at news content analysis, so we will look at what are the methods from natural language processing that can be used to extract information from news articles. So news articles are written in language, whether English or Hindi or Odia or Bengali. So written in natural language, and people who know the language can read them and understand them. But there is such a variety of articles by different houses. So one person cannot go through all the articles. So we want to do automated news analysis so that by doing this automated news analysis, we can identify the information that we are looking for. So when we want to extract information, we can try to extract information from the sentence. But in order to properly make meaning of the sentence, we have to understand the context of the sentence, which is the entire article of the document. And sometimes we need to also refer to other documents which talk about the same story in the past or in parallel. Now, in order to do natural language extraction, we rely on some sort of machine learning methods. But they are not always useful because when humans interpret language, we rely a lot on our background knowledge or other information that we know. So a lot of the time, we do knowledge enhancement and look at external knowledge sources such as Wikipedia, free media, etc., or some background understanding we have about causal knowledge structures. For example, in the domain of disaster, if we know that rainfall can lead to landslide, that information helps us in trying to interpret the articles. Thirdly, today, all of us know that large language models have been very influential. So many of us use systems like ChatGPT and many other such systems, which have been trained on a huge amount of text corpora, and therefore in them reside a lot of background knowledge. So in modern days, these large language models are used for NLP, and we will give an introduction to how they're used for NLP in general and how we have used for our purposes. So first, the overview of this talk, we will talk about multifaceted analysis of bias in news content, and we will see what we mean by that. And we will also look at how to extract events from news. Now, what we mean by multifaceted analysis of news content, if you look at this figure, you can see that on the left and right, we have different news articles. It's a schematic diagram which shows that different news articles from different houses, they are input to our system. And within our system, we try to identify for each article what are the aspects or subtopics they are talking about and what are their sentiment towards these subtopics. At the same time, we also try to identify what are the important entities or persons or stakeholders who are being talked about, who are being mentioned, or whose point of views are put in the news article. Because if we analyze them at an aggregate, we will get an understanding that if we compare different media houses, what type of leaning they have, whether they are putting more emphasis on one type of aspect, or they are, have a positive sentiment towards a particular topic, etc. So we also want to identify the different events which are there in the article, and we will see what we mean by events and the arguments and the roles that they play. The fourth thing that we want to look at is that sometimes when we look at a piece of news, that may have some bias. So we want to rewrite the news in a way so that we can reduce the intensity of bias and make it more factual. And this is another thing that we will look at. So this shows the full gamut of the work that we will be presenting today. So these are the key topics that I will be talking about. Extracting the mention of events and their arguments, identify different aspects of a news story, identify the sentiments around that aspect, identify the stakeholders in the news article and how those stakeholders are being portrayed in that particular article, and then try to find out the variability or bias that is shown by different media houses on a particular topic, and finally, how to reduce the sentiment to make the news reporting less biased. Now, in order to do this, we will be using a strategy of natural language processing. This is called information extraction. So information extraction means when you have unstructured data, such as text or images or videos, etc., how to extract structured information from that. So today, of course, we will deal with only text documents. We want to extract structured information so that we can work with the structured information. So this is called information extraction in the field of NLP. Now, in order to do information extraction, there are various approaches that people have tried. In the earlier days, people mainly used rule-based approaches, but for some time, people are using machine learning models. In machine learning, as we, all of us know a little bit that we have a lot of data, and from that data, we analyze the data to learn something. So typically in supervised machine learning, we will have some text, and along with this, we will have what information we can extract from the text, so that once we have models which are trained on that text, those models can be used to extract information from new text. And as I mentioned, we will also look at, what type of input we give, what type of knowledge enhancement we can do, and especially we will look at how we can use LLMs for different tasks in information extraction. Now, the first task we will talk about is identifying events and arguments from news articles. So let me first define what we mean by event. So an event is a specific occurrence or happening that typically involves certain entities, some location, some time, and it may involve some other arguments. For example, if you look at this sentence, the Prime Minister resigned after facing widespread protest. This is an event which is a resignation event. So if you have a sentence that there was a flood on the Kosai River, so the event is a flood event. So there are some events that we are interested in, and we have to identify whether, given a sentence, does it talk about some event? And typically associated with the event, there is a word or phrase that is indicative of the event, which is called the event trigger. In this case, the word resigned is indicative of the resignation event. For an event, we also may have arguments. So arguments are participants of the event. So if we say that the Prime Minister resigned, so the Prime Minister is the subject of the resignation event. So similarly, if we say the Supreme Court ruled in favor of the opposition leader in the corruption case, this is a ruling event, and Supreme Court is the agent of the ruling event. Opposition leader is the patient of the ruling event. Corruption case is the theme of the ruling event. So but for a particular event, we have event frame, and we have the specific roles that we are interested in. So given this event frame, we want to extract all arguments and their roles that we can from the given text sentence or the text document. So this is another example. Suppose we have this sentence: in Baghdad, a cameraman died when an American tank fired on the Palestine hotel. So the event type is die. In fact, this sentence, there are two events. One is a dying event, for which place is Baghdad, victim is cameraman, instrument is American tank. There's also in the same sentence a second event, which is an attack event, which is triggered by the word fired. The place is Baghdad, target is a cameraman, instrument is American tank, and target is a Palestine hotel. So from this sentence, we would like to extract these two event frames. Now, so before I proceed, I will ask you that whether this is okay, or if you need any clarification, please let me know. If you have any questions about the task definition, please let me know. So I'm proceeding. So
please proceed. Please proceed.
So if we look at this task now, there are various methods which have been used in the literature. The standard methods for event extraction, they can be classified into the pipeline approach and the joint approach. In pipeline approach, we have different stages through which an NLP system goes through. And so there are different stages of an NLP system, including low-level stages. Even at the high-level stages, there are different tasks. Like we have trigger identification, then event classification, argument identification, argument role classification. We do one after the other. Now, this is a standard way this was used to be done, but there are some problems with this approach. If there is an error at an earlier stage, that propagates to the final stages, and then there is no context awareness, goes one by one. Now, there are also other approaches which try to identify events, arguments, roles simultaneously using a unified model. But then they often work well, but sometimes they face the challenge when there are for example, if in one sentence there are two events, this is very challenging for these methods. So there can be interdependency among the event triggers, arguments, and corresponding roles. And many of these are not properly handled by existing methods. And all of this requires labeled data. Now, We looked at different methods that people have applied in the past on this. I will not go through the specific methods. And we tried to overcome some of the limitations of the prior methods by giving a new machine learning method. So our method is called pointer network-based event structure extraction. In the next slide, I will attempt to explain this method at a high level. So this method is based on an NLP machine learning model called an encoder-decoder model. And so some highlights about this method are, where this method is very successful is, this method is especially useful if in a single sentence there are multiple events. For example, multiple events or an argument is shared between the multiple events. For example, in this sentence, the police arrested the leader of a criminal gang who was responsible for organizing the recent bank robbery. Now, criminal gang is an attacker of the robbery event, and then arrested the person. It's also an argument of that. So in these cases, our system works very well. It can extract multiple event tuples even when they have a common trigger or some common argument phrase. And if there are overlapping argument phrase, for example, the leader of a criminal gang is an argument of the arrested event. And for the robbery event, criminal gang is the attacker. So these are called nested argument phrases. So our system does better than the other methods in such situations. Now, in order to enable this sort of multiple events, overlapping arguments, so we designed a representation of event tuple. So from a same sentence, we can get multiple event tuples, but each event tuple has this format. First of all, the sentence is taken as an input to the system. We have two, dummy tokens in the beginning, which have some role, and then there is the sentence. For example, suppose the input is orders went out today to deploy 17,000 US Army soldiers in the Persian Gulf region. Now, from this, we want to understand that this is a movement transport event. The trigger of this is the word deploy, and 17,000, deploy what? Deploy 17,000 US Army soldiers. So this is an argument called the artifact. And then for the same event, movement transport, the Persian Gulf region is the destination. So from this sentence, we get an event which has two arguments. Now, the way we represent it is, we give the start and end index of the trigger phrase. So deploy here is the trigger phrase, which is at position 7. The type of the event, the start and end of the argument phrase, and the trigger argument role type. So, this is, so the way this is designed is so that we can report events, multiple arguments, multiple events, triggers, etc. Now, this is a block diagram of a neural network system, and I will try to explain it at a high level. So on the left, we see that we have W1, W2, W3, Wn. These are the words of the sentence which are input to the block. Now, we do some natural language analysis of this sentence to get the part of speech of the words, the dependency parts of the sentence, so which shows the different words and how they are related to each other, the character entity and the entity embedding. So these things are found by different NLP methods, and those are added to the words. And for this, we also use BERT is a particular type of large language model. We use it for the embedding. Now, this sentence embedding is fed to our system. Now, our system has 5 blocks, major blocks. So first of all, if you look at the below, we have a sequence generating network, which is based on a LSTM with attention, which is a particular type of neural network, a recurrent neural network with attention. So for a particular sentence, we can generate multiple events, and these event tuples will be generated by this LSTM. So if there are 3 event tuples, they will be generated one after the other. Then within this dashed box, we have 2 pointer networks, pointer by LSTM. So the top one is for finding that trigger phrase span, the trigger word, like we had deploy as the trigger word, or it can be a trigger phrase. And then the lower one is for finding the argument phrase span. And the trigger phrase span also is an input to the argument phrase span. And both of them take input from this sequence generating LSTM. Now, following this by LSTM pointer networks, we have some feed-forward neural network, which shows for each event type what is the probability of this word being the start of the phrase and the end of the phrase. And these are collected by these 2 classifiers given in green here. So this classifier looks at the start and end probabilities of different event types and comes up with one event type. And then the second classifier looks at the different argument types and comes up with one role type, which creates one event tuple, and multiple event tuples can be created. So this architecture is novel and helps in generating multiple event tuples. Now, I will not go into the details, but we compared our system with the other systems in the literature, and we found that in most cases, for the different tasks, our system performed better. For example, in the trigger identification task, it always performed better. Trigger classification. For argument identification, most of the cases it worked better. In argument role classification, it was competitive with the other approaches. So, but we specially noted that in those cases where the same sentence have multiple events or argument overlap, in those cases, our system performed significantly better. So if you look at this table, the last column corresponds to multiple events. So we see that for multiple events, our system is doing significantly better. Our system, the PEAC system in blue, it is doing significantly better than the other systems for count greater than 1. Also, when we have for argument identification, for the case when there is argument overlap, in that case also our system is performing better. Now, that was the first part of the work on event extraction. Now, before we proceed to the second part, where we will talk about news bias analysis, I will give a very brief introduction to what is an LLM, in case that, because there's a mixed audience here, because we are using these LLMs for the next part of the work. First of all, I'd like to say that large language models, so the LLMs are very popular nowadays and many people use them. And what is an LLM? LLM is a language model which has been trained on huge amount of text formats. So today we have a lot of electronic documents, lot of text. So LLM has been learned on huge amount of text. And because of this and the different ways that they are learned, it's very simple ways, the ways that they are learned, they are understood that they can import a large amount of the world knowledge. So LLM typically is a deep neural network with billions and now trillion parameters. And because of a lot of these parameters, these LLMs are very powerful and they are learned because a lot of human knowledge is there in written text. Now, because we cannot read a lot of books, a lot of documents, because our time is limited, but an LLM can read all these documents, all the documents which are available, and it gets very powerful. So By being trained on these documents, LLMs gain a broad understanding of language and is found to encode a lot of knowledge. So, and typical supervised machine learning, when we give data to a machine learning model, we have to give labeled data, and labeling data is very time consuming. But an LLM works in a self-supervised mode, that you do not require extra labeled information. From the raw text, it creates some labeled data. For example, it takes a sentence, it takes a sentence and masks certain words. That's called masked language modeling. And the LLM has to predict the masked word. Or let me know if there is any question. Or if you have a sentence and you want to predict the next word, that is called causal language model. So these types of learnings can be designed based on the raw text that we have. And by being trained on these types of tasks on vast amount of text corpora, using powerful deep neural network models, typically based on an architecture which we call the transformer, pre-trained in a semi-supervised way, the LLMs are able to capture a lot of knowledge. And they can be used for a variety of tasks like text classification, question answering, entity tagging, summarization, dialogues. Now, LLMs are based on something which we call a transformer. I'm not going to go into the details of a transformer architecture, but transformers there are two blocks in a transformer, the input, which is called the encoder block, and decoder block. Some LLMs only use the encoder block, like the ones which do masked language modeling, such as BERT. Some use only the decoder, such as for causal language modeling. And some use a combination of encoder and decoder. For example, for machine translation, summarization, etc., where the input is a sentence, let us say in English, and the output is a sentence in Hindi. So, but encoder and decoder are two different blocks of a transformer, and an LLM can have one or both blocks. Now, as we said that LLMs are based, these language models are based on transformers. There are encoder-only LLMs like BERT, decoder-only LLMs like GPT, and encoder-decoder LLMs like BART. And there are many many newer models and with different names by different large companies. Now, an LLM is trained on a huge amount of general text, and it is able to encode broad knowledge. And you can still get a lot of information on your specific task from an LLM. But if you really want to make it task specific and do better for a specific task, then you can have an LLM, you can train an LLM for a particular domain. That's called domain specific LLM. Now, if you want to work on a particular domain, you may not have a large amount of documents in that domain, and that LLM will not be so powerful. So what is often done is that you take a pre-trained LLM, which has been trained on the general domain, and then use smaller task-specific data set to fine-tune the parameters of an LLM so that it is better for some specific task. So now, even then, nowadays, these effective LLMs, they have billions of parameters, used to have. Nowadays, LLMs have trillions of parameters. Now, even fine-tuning those trillions of parameters take a lot of time. So now there is an even easier way to tune an LLM or use an LLM, and that is called in-context learning, or by giving prompts. So in fine-tuning, you have an LLM which have some parameters, I mean, billions of it, huge number of parameters, and you fine-tune the parameters on a smaller data set. But if you cannot, if it's not possible to fine-tune because it will require a lot of computational power, The answer to it, as was shown in the GPT-3 paper, is in-context learning, where you do not touch the LLM parameters at all. Instead, you provide an input, and in the input, you give your context or your separate task-specific input you give in your given input without touching the parameters of the LLM so that you can get output. So that is called giving a prompt or in-context learning. So in-context learning refers to the ability of an LLM to understand and generate response based on the context that it provided. So for example, in this picture, we have this LLM whose parameters are fixed. Now, if you want to do a task on sentiment analysis, you can give some examples that delicious food, sentiment is positive. The food is awful, sentiment is negative. Terrible dishes, sentiment is negative. So you give some examples which you label, and then you give your query good meal and ask it to find the sentiment. So you specify what you want and give some examples from the task and feed it to the LLM to get the answer. So this is called in-context learning. Prompting. Prompting is the most common way of using in-context learning. In there also, you have zero shot and few shot. In zero shot prompt, you just give the query. You do not give any examples. For example, you say classify this sentence. The new policy will empower communities and foster economic growth. And you ask for the sentiment. You don't give any examples. In few shot prompting, you give some examples. You give some sentences like together we can build a brighter future. Sentiment is positive. Government corruption has eroded trust. Is given as negative, and then you give your sentence to classify. Now, in some tasks, even with zero shot, you can get good answers. But in many cases, if you give few examples, then the system gets better. And then there is also, just to take it further, so now people also talk about parameter efficient fine tune, where you fine tune on only, in a normal fine tuning, you tune all the parameters. In parameter efficient fine tuning, you only fine tune a small number of parameters. You leave most of the parameters fixed. You only tune some of the parameters, and for that there are different methods. Like you freeze most of the layers, few parameters you fine tune. Then there are other methods which we will not talk about. The fourth method we have used is called soft prompting or prompt tuning. So when we say the prompt is classify the sentence or find the sentiment of the sentence, this is one prompt. Now, suppose this prompt is not doing well. We want to word it in another way so that the system gets better answer. So we can do prompt engineering by manually trying different prompts. An alternative to it is that don't give the prompt. Just give a vector and give some examples of the task and let the system learn the prompt. So that is called prompt tuning or soft prompting. Now with this, some very high level introduction to LLMs and these tasks, we come to our task and what we have done. So the next task that we will talk about is identify aspects from a news story and analyze the sentiment. And this paper was recently accepted in ACM Journal on Computing and Sustainable Societies. Now, as I said, that we want to talk about media bias. So in this work, we have focused on 3 types of bias. So first is, if we look at a news story reporting a particular event, so we find different types of bias. One of them is selection bias. So selection bias happens when the particular news house or the journalist only talks more about, suppose that particular news story has different aspects, and suppose it only selectively talks more about certain aspects and less about other aspects, then we can say that there is a selection bias. For example, if a news channel only covers crimes committed by one ethnic group, while ignoring similar crimes by other groups, creating a distorted perception. This is called a selection. This is an example of a selection bias. Second type of bias that we will discuss is called statement bias, which involves framing language in such a way that favors one side of the argument. So you put some bias, put some sentiment, positive or negative sentiment on certain aspects. That is called statement bias. For example, if you describe a government policy as a draconian measure instead of strict regulation, in the first case, you portray the policy negatively. Whereas in the second case, you give a neutral portrayal. The third type of bias that we will look at is called stakeholder bias. So this happens when media favor or prioritize the perspectives of one group over the other. For example, if you say that there are various stakeholders to a particular story, we have government officials, we have private corporations, we have political parties, we have citizen activists, common people. So all of them have different viewpoints. So if a news house selectively only portrays the point of view of few of them, then we can say that there is a bias. For example, a news story about labor strikes might only focus on the business owner's perspective and ignore the grievances of the workers. So these are three types of biases. So what we want is to detect the bias, or rather we don't call it bias. We say that we compare different media houses and see how they vary in the coverage. Now, if we take a particular story, there are different aspects of the story. And so a news aspect is a specific angle or perspective covered in news story. For example, one of the case studies that we took up is the Indian Agricultural Acts 2020. So some of the aspects that we have identified for this story are farm laws, which focuses on the content and implication of the farm laws. Then the farmer protest. Third is government action. So if you say the government introduces a new farm laws to modernize agriculture, that belongs to farm laws aspect. If you say thousands of farmers march to Delhi in protest, this is a farmer protest. Supreme Court stays implementation of farm laws, this is government action. So these are different aspects of the story. We want to identify the aspects so that we can see whether there is selective coverage of these aspects and what are the sentiments around those aspects. Now, suppose you take the second aspect, which is farmer protest. Now, if you have a sentence which says the peaceful protest by farmers and inspiring demonstration of democratic rights in India, this shows a positive sentiment towards farmer protest. Several states have gathered in New Delhi to protest the newly passed farm laws. It's a neutral sentiment. This is only giving a factual statement. But if you say the protests have disrupted daily life and economy, leading to widespread traffic jams and chaos, that's an example of a negative sentiment. Now, why are we interested in sentiment? Now, if we can automatically identify the sentiment about the different aspects for a particular news article, this provides a clear picture of the narrative which is surrounding the news event as portrayed in the media, helps us to detect bias and slant at a granular level. At a high level, we can say Agricultural Act, what is the policy, but unless we go at the granular level, because Agricultural Act has different aspects. One is the farm law themselves, the other is the farmers' protest, and so on. So we want to identify for each different aspect what is the stance of the media house. Thirdly, we want to look at the stakeholder perspective and analyze how different groups are portrayed in the media. Now, for this work, we had created data set on 4 topics: Agricultural Act, then the demonetization, Citizenship Amendment Bill, COVID-19. So these 4 were just topics were chosen by, we looked at news for a particular period, and we chose some of the important news stories which had extended coverage during this period. Now, once we have chosen this topic, we use the GDELT website. So GDELT is a project which has a global the different events that are happening, it flashes those events in real time. So from GDELT, we collected documents on these 4 topics. So if you look at this table, in the last column, we show how many documents we have from each topic. For controlling COVID, we have more than 25,000 documents. On Citizenship Amendment Bill, we had only 590 documents and so on. And then we have the different aspects, like Agriculture Act, we have 4 aspects, including international involvement. In CAB, we have 4 aspects, etc. So we have these different aspects. For controlling COVID, we have healthcare situation, lockdown, testing and vaccination, government action, effect on public life. We have these 4 topics. And now on these aspects, we, among the 9,000 documents, we were not able to annotate all the documents, but we annotated 45 documents and 495 sentences in those documents. So this shows the data set that we created. And this shows the sample annotation that we have. For every sentence in this annotated data set, we find out what is the topic of this sentence and what are the aspects it's being talked about and the sentiment along that aspect. For example, in this sentence talking about farm laws, there's a positive sentiment. In this sentence talking about Citizenship Amendment Bill, there's a protest aspect, there's a neutral sentiment. In demonetization, in this sentence, there's a note ban aspect and negative sentiment. And here in this sentence, as the lockdown hit India to stop the spread of coronavirus, lakhs of people lost their jobs. This is a topic, controlling COVID in India. There are 2 aspects here. On lockdown, it is neutral. On effect of public life, it is negative. Now, once we have prepared the data set, we work on 2 tasks. One is extracting the aspect term and the category, and then aspect-based sentiment classification. Now, if we look at the gamut of NLP tools which are available, people work on the following approaches. There are knowledge-based approaches using dictionary, ontology, etc. There are machine learning-based approaches, and there are LLM-based approaches. Now, for this task, we find that the LLM-based approach, works very well. So what we have done is that for these 2 tasks, both aspect extraction and aspect-based sentiment classification, we have converted them to a natural language inference task. What is the natural language inference task? In an inference task, we have a premise, we have a hypothesis, and we try to see whether from the premise, the hypothesis is implied. For example, if you say the cat is sitting on the mat, and the hypothesis is cat is on the mat, the cat is sitting on the mat entails a cat is on the mat. But if you say the cat is sitting on the mat, and you have a sentence, the cat is in my home, it is not implied. It is neither implied nor contradicted. If you say the cat is sitting on the mat, and you say the cat is on the bed, then there is a contradiction. So this is the standard task of natural language inference. Now we take our tasks of aspect classification and sentiment identification, we transform them into an NLI task. For example, suppose our given sentence is the premise. Suppose we say the government has maintained that the new laws will bring farmers better opportunities and usher in new technologies in agriculture. This is the premise. And then we want to classify the aspect and classify the sentiment. If you want to classify the aspect, suppose there are 4 different aspects. So we create hypothesis for each aspect. So suppose we say the sentence is about farm laws. And if there's entailment, that means it is indeed about farm laws. Contradiction means, and neutral means it is not there. Similarly, if you want to know if there is a sentiment of positive or negative around farm laws, we can put those as hypothesis, and then we can use it. So we try to formulate this task as an NLI task. And then we use a large language model, a pre-trained large language model, which is BERT-based MNN. We take this language model and we fine-tune on the data set that we have created, so that we have a LLM which has fine-tuned for these 2 tasks. So this is the overview of our framework. For aspect identification, we form an NLI problem. So first of all, we do a classification of the particular topic. And in that topic, if we have 4 different aspects, for each aspect, we frame an NLI problem. And the output to that is fed to the sentiment classification task. In the sentiment classification task also, we have 2 NLI problems. One saying that this has a positive impact. Suppose the aspect is government action. One hypothesis is government action has a positive impact. Second hypothesis is a government action has a negative impact. From this first LLM, we get positive, neutral, negative, their probabilities. Second one also, we get those probabilities. We average or aggregate them to get the final aggregated setting. So this is the overview of our system. And this system, we have tried with the standard baseline methods. So standard method, you can still use an LLM without using an NLI method, which is used previously. So for the aspect identification, previously a multi-level classifier based on the BART LLM was used. And for the sentiment classification, previously multi-class classifier based on BART was used. And we find that our NLI-based approach does better than those approaches. We also find that because we have limited, data set, we also see what is the effect of the size of the data set on the accuracy of the classification. For the aspect identification, we see that we don't need a lot of data set. With a small amount of data set, we can still able to identify the aspect fairly accurately. With sentiment classification, we see that we get reasonable accuracy with the given data set size that we have. Now, this is how our system works. So we give an article, and in that article, it identifies the aspect and identifies the sentiment along their aspects. The next task, the third task that we look at is classifying the news stakeholders. Now, as I have said before, the news stakeholder is an entity which is mentioned in news article, which plays a significant role in the reported events or topics and are directly or indirectly involved or are impacted by the news story. For example, for a particular news story, we may have policymakers or government officials as a stakeholder, political opponents or opposition political parties as a stakeholder, consumers or ordinary citizen as a stakeholder, civic society as a stakeholder. Now, for every topic, the set of stakeholders may be different. For example, farmers is a stakeholder in the Agricultural Act, but is not a stakeholder in COVID. So there are certain stakeholders which are very common, which occur across multiple topics, but there are, for every topic that we take, there may be a few new stakeholder classes. So our task is to identify the stakeholder groups related to a topic and to group them correctly. So the challenges are their news domains are heterogeneous and some stakeholders are domain dependent. Now, typically, the standard approaches to stakeholder classification is having a manually annotated data set and doing named entity recognition and doing classification, etc. But that is not able to scale up when you have new stakeholder types. Now, in our system, we go through the following phases. For each, we use the appropriate methods. So first step, we do entity phrase identification. So we use a tool by which we can identify the named entities in a given document. For example, for the first input sentence, we see that there are 2 named entities. Prime Minister Narendra Modi, type person, Reserve Bank of India of type organization. Second stage, so we now suppose the same stakeholder. So if we look at a full document, we identify the named entities in the document. Now, maybe the same entity is being mentioned in multiple sentences. So we try to identify all mentions of the same entity. Sometimes it is complicated because you do not use the exact same phrase for all mentions. For example, in the second thing, if you look at this article, we have Health Minister Harsh Vardhan, he, Vardhan. There are three references who refer to the same entity. So we have to identify that. For this, we do co-reference analysis. In the third stage, suppose we take Health Minister Harshvardhan. Now, we look at multiple news stories where the same person is being mentioned. So we have to do cross-document entity context, for which we use different methods like Levenstein distance between the entities, Jarrow-Winkler similarity, knowledge sources, etc. So we can identify the mentions of the same entity across different documents. Fourthly, we use some background knowledge from Wikipedia, where we can get more information about these entities. Now, once after we have done this, we again use the entailment, natural language inference, in order to do the classification. So we give the entity phrase and the textual description of that entity, and we want to find out the label. For this, we formulate an NLI task, and we're able to find the entities. Now, so this shows an example. Suppose here is a document and the entity phrase is Urjit Patel. Now, we have, let us say, these 5 types of stakeholders known: government, opposition, banking sector, citizen activists, private sector. So for all these 5 different stakeholders, we formulate one NLI problem, and for each NLI problem, we get an output. And from that, we combine them to, in this case, we say that Urjit Patel belongs to a stakeholder belonging to the banking sector. Now, for stakeholder classification, we have used 2 different methods. So earlier we explained what is zero shot, what is few shot. In zero shot, you give no example. You just give the document and then say, find out if it is of type government, find out if Urjit Patel is of type opposition, find out if Urjit Patel is a type activist. So we do not give any extra knowledge. Okay. So we have different news articles. So for the same entity, let us say Urjit Patel, we find out the mention of the same entity across multiple news articles to collect the cross-document entity context. Along with it, we find out if for that entity there's a Wikipedia page. From the Wikipedia page, we get the text information out of this. And then for all the stakeholder types belonging to that domain, we use an NLI problem on a language model in order to do the entailment. So we do it on the label dataset that we have. We train that NLI task on this label dataset. We train the language model. Now, when we train the language model, we modify the parameters of the language model. So we have a fine-tuned language model. So on the left, we have the training phase where we train the model. And after we train the model, we have the changed or fine-tuned language model. And then this fine-tuned language model is used on a new mention. So we have news articles, Wikipedia excerpt for a given entity, and that is the premise. And we have the different stakeholders of the new domain. So for example, suppose we have trained on a particular domain. When we go to a new domain, some of the stakeholder types we already have seen in the training set. Some of the stakeholder types may be unseen. So suppose judiciary was not there in the earlier training. So it is a new stakeholder type which has come. But when we use the fine-tuned language model, we use it both on the seen types of stakeholders and also unseen type of stakeholders, and we find the results. And we use 2 LLMs. We have experimented with 2 LLMs, Robata and BART, for this. Now, if we look at the 5 domains, so here we have added a 5th domain, which is the Article 370 abrogation. So on these 5 domains, if we look at the different stakeholders, the ones in black are there in all the 5 domains: government, opposition, citizen activists, bureaucrat. But for Agriculture Act, we have farmers, an international figure. For demonetization, we have banking sector, private companies. For Article 370, we have international figure, judiciary, Kashmir people. So these are topic-specific stakeholders. Now, this is the statistics of the data set that we have collected. So we also have, so in the second table, test scene, you see, we have collected in the training set, we have 5 types of stakeholders. But in the test set, we have 4 new types of stakeholders. Now, so once we have this, we can, let me know if there are any questions. So we can use this on this system. The other thing that we tried was that, so for this original system, we have to give a fixed prompt. We also tried prompt tuning. In a prompt tuning, as I mentioned at a high level, that you don't give a prompt, you give a vector and you give some training data and this prompt is learned. So that's called prompt tuning. And we tried both, our original model as well as prompt tuning. And we find that we have experimented with 3 different types of prompts, which are shown in blue, red, and yellow. We have used 2 different models, BART large and Robata. So we see that with different templates, how BART large and Robata performs. And when we use prompt tuning, we see for all 3 prompts, it's not that the results improve, but for all 3 prompts, this prompt tuning gives decent results. So this is our finding on this. Now, once we have identified the stakeholders, we want to find out the sentiment along that stakeholder. So why is it important? So different news reportings, they will show polarity towards specific political entity. So for example, if you're looking at news on US election, you will see that certain media houses will always portray positively about one, say, Republican and negatively about Democrats. And the other set of media houses will do the exact opposite. At least there are some news channels which do that. So there's sentiment polarized towards specific political entities, which show the ideological stance of the outlets. So therefore, we want to get an insight into what type of bias is there. But this task is challenging because there's a lot of subjectivity, etc. So we worked on this. So existing approaches work with machine learning methods. So we explored LLMs to predict entity-specific sentiment. And for that, we used several types of prompting, the zero-shot prompting, chain of thought prompting, and self-consistency, which I will explain in the subsequent slides. We also created a new data set. We use a standard data set which was there for this. And we also created a new data set called WPAN, which stands for Worldwide Perception Analysis of Nations, which is a new data set focused on global politics, which contains news articles pertaining to specific nations, which was India, Russia, and Israel. And for India, we included media sources from Pakistan and Bangladesh. For Russia, we selected outlets from India, UK, US. For Israel, we took outlets from India and Pakistan to see the portrait. Now, we work with different prompting methods. In zero-shot prompting, use an LLM where we give an input text. For example, we say Brazil President Luis, etc., Times of Israel. And then we say target entity Israel. And the prompt says, given the context, what sentiment label is expressed towards the target entity. Only we give the prompt, we do not give an example. In two-stage prompting, along with the prompt, we also want to extract the reason why the answer is what is given. So, for example, if you say, given the input, how is target entity portrayed in terms of sentiment, the answer is. So you don't want the answer only, you also want to understand why the answer is so. So you give an intermediate prompt which says, how is the target entity portrayed in terms of sentiment? So if you give the same thing to a particular sentence to this method, it will generate, in this text, Donald Trump is portrayed in terms of sentiment as a strong leader who is determined to take action on the issue of gun violence. Many Republicans are divided on various proposals, etc. This is the intermediate output. And then from this generated text, you get the final sentiment. So this is called chain of thought prompting. And as has been seen by different people in different tasks, chain of thought prompting often helps you get better answers. And this is what we found. So we looked at standard few shot prompting, where we just give some examples and the answer. And we give examples of chain of thought prompting, where we give the input, the rationale, and then the answer. And the third is self-consistency, which we will discuss. So in COT prompting, the language model is guided to think step by step in solving complex tasks by breaking the problem into simpler problems or multiple problems. You see, first understand how the person is portrayed and then find the sentiment. The second thing that we tried is called self-consistency. In self-consistency, what happens? Instead of getting one answer, you get the LLM to give multiple answers. So in the LLM, there is the output, there's a beam search. So you force the LLMs to not just take the most probable path, but to follow multiple paths. So you get multiple responses to the same prompt using different parameters, and then you aggregate the answers given by the different prompts. So this is an example of a few shot prompt, COT prompt, and self-consistency prompt. We have chain of thought prompt along with self-consistency. So this gives the best result. And we have used the following data sets. The first two are standard data sets which are there. The percent data set in 2 use cases and the new data set that we created. And we used 3 different types of LLMs. And we tested with different zero shot and few shot methods. And as expected, that our method with few shot prompting using COT and self-consistency, that works best for this task. So to summarize, we find that pre-trained LLMs are capable to capture sentiments, but in context learning, the system performs significantly better in few shot settings than chain of thought and self-consistency help. Now, the final stage of the presentation, I will talk about. Now, with all these tools, we actually try to analyze different news media and try to find out what are the variabilities or biases in their presentation. Now, these are some examples that I have taken from an article on the topic of farmer protest. And we see that in different media, the ones in green are pro-farmers, the ones in red are anti-farmer, not pro-farmers, anti-farmers, pro-farmer protest, anti-farmer protest, and the ones in blue are neutral towards farmer protest, or give a more balanced view. So we see that there is a lot of variation in news reporting in which stories are selected, and we have already talked about the different biases. And so these are the 4 topics that we have taken along with the time ranges, typically between 2019 to 21-22. Now, with the tools that we discussed before, this shows on the topic Agriculture Act and on the topic controlling COVID in India. If we look at different media houses, for example, in Agriculture Act, we look at INAE News, News 18, Telegraph, Indian Express, etc. We find the fraction of positive, neutral, and negative articles. Overall, we don't see there is much variation if we look at the topic as a whole. But then, if we look at different subtopics, then we see more variation. So similarly, this is a topic demonetization. This is a topic CAB. So we compare, these are Indian media outlets. These are outlets from foreign international media. So we try to see how they have portrayed positively, negatively, or neutrally. We also find out on different aspects how this coverage percentage vary with time. For example, if you look at Agriculture Act, initially there is, farmer protest, there is more coverage, then there is less, then there is more. So green is government action. Initially, there is less coverage, then there is more coverage. So these are some things that we look at, and we try to look at the timeline and try to find out why this happens. But we see that overall, the variability is not that much, that significant. So what we'll go is that we said that we want to identify, we have already identified different aspects and the aspect specific bias. Based on that, we have worked out a formula to quantify the bias of different media houses. And the way we do it, we look at the fraction of positive and negative coverage by a particular or one group of media house against the reference set of media houses, which typically contains all the media houses, and see that deviation. So that is called our selection bias. I will not go through the details. So this is the candidate selection bias minus the reference selection bias. Similarly for statement bias. So we have done this quantification. Now based on this, now we look at, say for Agriculture Act, we look at the 4 different topics, and we look at, in this we are showing 4 different newspapers, Indian Express, Telegraph, Hindu, TOI. We see that in Indian Express, for international involvement, there is more negative coverage. For Hindu, for farmer protest, there is more positive coverage. Indian Express farmer protest has negative coverage, and so on. So we can see that the difference in the portrayals by these media houses can be brought out if we look at different topics. So if we look at overall bias, there's not so much difference. But if we look at different aspects, we see that some media houses are more positive, like Hindu and Telegraph are more covering pro-farmer, whereas there's more anti-farmer coverage in the other houses, and so on. Similarly, for demonetization, we look at different aspects of demonetization and the coverage by different media houses so that we can compare. Then we look at different international media houses. So we have India in blue, US in red, and UK in yellow. And we see that if we look at COVID, we see that overall there's more positive coverage on COVID control in India by India media houses, more negative media coverage by foreign media houses on India COVID control, and especially more negative in UK. So similarly, so once we have this tool, we have gone through all this topic and tried to identify the types of bias that we can see. I will not go through all those details. So this is aspect level statement bias of foreign media versus Indian media. So we see often that the foreign media is more critical about different aspects compared to the Indian media. So in this diagram, we show together selection and statement bias to see that, whether, so this quadrant, we have more selection bias and more statement bias, less selection, less statement. And we see that the foreign media houses typically have more negative coverage. So these are temporal, these things. So I'll not, so this is on the stakeholder classes. So if you look at COVID control in India, we look at different stakeholders like government, opposition, scientists and researchers, citizen activists, international figure. We can look at, how much they are being covered and what is the sentiment of their coverage in different media houses. So, of course, we cannot go into the details, but the final remark I want to make is that these models we have shown on, specific news topics. But what if we want to do for another news topic? How much work does it involve? In order to do that, we check how much the model is quoted. For example, if we develop the model on 4 topics, Agriculture Act, CAB, controlling COVID, only on these 3 topics we developed the model and took demonetization as the new topic. If we take only 5, only 10, only 15 examples from the new topic, then we see how much we are able to do for the aspect identification and sentiment classification task versus using all the training examples. So we find out that if we take 10 to 15 examples or even 5 examples, we can easily port it to a new topic. So the finding is that the tool that we have developed, we can, with a very small number of examples, use it on a new topic to analyze bias on that. Okay, I think with this I will stop. I had some other topic also, but I think I will stop here and I'll take questions from you.
Thank you, Professor Sudeshna Sarkar, for your excellent talk. Now, actually, we'll have few questions and answers. May I now request Mr. Sanat Kumar to ask some question. You have already raised the hand.
Yeah, yes. Madam, this talk was excellent, but as a layman, it is clear that I have to understand much more. I have to go deep much more. But one or two comments I will try to make with like that. Number one is taking your final thing. Foreign media is negative towards India. Foreign media is, particularly BBC, for example, portrays everything negative about India. Everybody knows, no? At least I know, seeing TV and reading newspapers, etc. So, what is the effect of your software? I mean, in your finding, who uses them to control? Maybe people who place ads to newspapers, they may use, maybe I don't know, but who uses them? That is number one. Number two is that you said you use Wikipedia. Now, out of experience, I can tell you Wikipedia is not always right. They are also very much biased. So yeah, I think you have to take that into account. Then the third point is that when you're talking about demonetization, you said it has got a negative sentiment. I know, for example, many people consider demonetization very good. Some people consider it negative, particularly business people, but many other common people, including me, we thought it was very good. So now, if you already assign a negative sentiment to the demonetization, then your result may be wrong. So maybe my questions are wrong. That is possible. So kindly see what is the answer.
No. First of all, let me tell you that our role is to provide a tool, create a tool. So I have nothing, I do not understand the media bias, the actual domain, what is happening. So we are trying to create a tool so that using the tool, one can understand the variability, so that suppose you are a consumer of news, you want to look at not just one newspaper, you want to understand on this topic, what is the overall picture. So your first question on foreign media, that particular example that I showed is only for government action on COVID by British media. So, and we saw that it was negative on that topic. I cannot comment in general from my point whether a foreign media is always negative. For this particular, actually, the graphs that I showed is where there is a difference between India and foreign. There were many other aspects where Indian and foreign media did not deviate so much. So in this, we saw that there was a difference. Your comment about the Wikipedia is okay, but for Wikipedia, we are not taking their take on that. We are just using it to know more about an entity. So if we already have some background on the entity, we can say, okay, this person is in the banking sector.
Information given in Wikipedia could be wrong.
It could be wrong, but yeah. So you see, when we look at news, the news also, there's also fake news. We just go by what is there, and among the open source, source of knowledge, we take Wikipedia. Your third comment on demonetization. Demonetization, of course, it's not all negative. There's a lot of positive, lot of negative. In fact, what we also said is that suppose on one particular aspect, if you look at it is mostly positive or mostly negative, if you look at positive, negative, neutral, which one is more prominent, we see most of the newspapers on a topic are more either on that all are positive or on that all are negative. So we do not see that there is a lot of difference in whether they are positive or negative. But when we actually quantify, we do not look at whether it is positive or negative. We say how much positive, how much negative. We take the average and we put the reference. And we are saying how much more positive from reference, how much more negative from reference, so that we can amplify the bias. Actually, we did not find, very frankly, that there is among the major media houses within India that we took, we did not find there's so much variation. But we did find subtle variations. And that is why we only looked at the relative variability. rather than whether we did not find, even in standard newspapers, we did not see that they always said something is bad. It's always they will not say demonetize. They will say bad things and good things, bad things on certain aspects. Maybe they will say the effect on common man is bad. They will say something else is good. Again, in different stories they publish, there are different shades of this. So it is not all that, just all Democrats is good, all Republicans is bad, or vice versa. So we found out that in Indian media, these topics, they are not polarized. They are not polarized. So the same media house are covering different aspects of the topic in different ways, but we are still trying to quantify if there is a difference in the percentages.
Okay, one last comment, madam. Last, you talked about input. Is it the human input by keyboard to the program, or how do you give the input? How do you present the input to the program?
Input is a text. Input is a document. You can give it from a file or you can give it from the keyboard. But when you have an LLM, you can through a program, you can give through a file, you can give through an input, you can give. So this is an input to the system and output from the system.
No, is the input given during the running of the program? The program is putting out something.
We have a program running which has different blocks, and there's an input that the program takes, which we prepare the input from the different documents and the input prompts that we create.
Thank you, madam. Thank you very much.
Thank you, Professor, for your questions.
Any other question?
Good morning, ma'am. I have one doubt. So in prompt engineering, especially in soft prompt engineering, you have mentioned that if the user has to provide a very small set of data from which the model learns, and then it works based on that learning, then there is a possibility that there can be overfitting issues. So then how that model will handle in real time if something is happening like that?
Right. So very valid question. You see, in standard classical machine learning, we are always afraid of overfitting. Now, what we have is a very large language model, which we like to think it already encodes a lot of knowledge. It already has a lot of knowledge, lot of parameters. Now, the few examples we are giving is actually being, we are not giving extra knowledge like Wikipedia, etc. But whatever knowledge is there in the language model, that is the main solid background knowledge. Even when we give a few examples, we find that in many cases, using whatever it knows, they are able to do well. So this is what we observe when we use the large language model. Like many of you may use ChatGPT or many other, Copilot or whatever, Gemini. So there are these language models which already have a lot of information in them, some way, which we don't understand in the neural networks. So when we even give a few examples, it helps. But if the examples are wrong, of course, it will not work. But overfitting is magically not so much there, even though we have so many parameters, because we are not changing the parameters. Overfitting happens when we change the parameters. Our model is fixed. We are only giving the input to give it some direction. And sometimes if we give a small number of appropriate inputs, it helps. Because the model already knows some things. With one or two examples, it can catch it. So this is the observation.
Okay, thank you.
Any other question? I have got one or two small questions.
Okay.
One thing that you find, and it is also clear from your presentations, that there are actually a lot of biases. So, be it a political situation or it is a military situation or farmers' agitation, a lot of biases are there. Now, is your actually model or method, can it really bring out actually what is the truth? Because the truth path is actually totally ignored.
I think, Professor Acharya, that's a very pertinent question. So people talk about factual news, fake news, or fabricated news. So, there's a lot of work on that, but we are not addressing that. What we are trying to address, even if we assume that it's factual news because we are taking from standard media houses, we are not going into whether it's fabricated or not. But the same news can be presented in different ways. For example, in fact, the last part of the talk, which we did not give, we tried to there show that, the same statement can be given, an example, but the same thing, when you say that, if you say that he alleged that the bill ignored Indian Muslims, it's very negative. But if you say he claimed that the bill overlooked Indian Muslims, you're making a factual statement. So there are subtle ways in which you can convey bias by the way you frame your statement. When you say farmer protest, you can say that the farmers are marching because they are sad, or you can say the farmers are marching and creating chaos. The same thing. There are multiple aspects that you are presenting. We are not looking at fake versus fabricated, but which aspect is being given more importance. When you say selection bias, you select what you want to portray. Everything, demonetization has positive and negative aspects. As Professor Sanat Kumar said, there are more positive aspects. It may be, but there are some negative aspects maybe. But some news houses may portray more of the negative aspects, some may portray more of the positive aspects. All are true, but what you select to present, that is what we are looking at. We are not verifying the factuality of the presentations.
Okay. Now, actually, I will request those who are present, please actually show your, you go to actually this camera mode. So you're actually photograph, okay? And we'll take a snapshot of that. Is many more, some 14 people are there. Okay. So let us actually take a snapshot. Now, Professor Sudeshna Sarkar, thank you very much for your excellent talk. And it was really illuminating for us. Now, two things actually I would like to take. One actually is your permission. We are recording all this, your talk. Do you have any problem that if you circulate among our other members?
No, I have no problem.
Okay, it can be circulated. Thank you. The second part is this our INAE Bhubaneswar chapter would like to send you a small memento as a token of appreciation of actually what you have done. Okay.
Thank you.
And that you will get by post. So with these few words, we come to the conclusion of your excellent talk here. And in future, also we'll get in touch with you that to have few more such excellent talks. Thank you very much.
Thank you, Professor Acharya, and thanks to all the audience.
Which one?
Thanks to everybody.
Okay, thank you. Namaste.
Okay, thanks.